All right, all right, all right. Welcome back. We're doing concavity and inflection points. Concavity is curvature, okay? It's a great way to think about it. Concavity is curvature. So we say something is concave up if it's, whoa, if it's curving from left to right. Ooh, I want that. So it's doing, oh, I want a different color there. Let's do something that stands out a little bit better. It's curving upwards. Here, it's like if I went further, I could see, and I keep curving, it's curving upwards like that. So we call this concave up. I tend to abbreviate this as CU. And when something, and so it looks like if I did this, I'm making a bowl, it kind of holds water there, okay? That's what I mean by that. That's what I put like right here, holds water. And then that happens actually when, so it's happening when f prime of x is increasing right there. So if it's increasing right there, the derivative is getting steeper and steeper, going further up like that. It means the second derivative is greater than 0, which is kind of neat. So what we're going to use to take advantage of is second derivatives. When we do concave down, it means it's curving down, like doing like that or like that. If I finish the arc, and it looks like if I had a bowl like that, water would spill. So that's one way of it. Like if it helps you remember thinking of it as a bowl, when it holds water, that holds water, it's up. The bowl is facing upward. And if it doesn't hold water, the bowl is facing downward. It pours it out. Okay? In both cases, we're looking at the derivative, second derivative. If the second derivative is greater than 0, it's concave up at a point. And if it's less than 0, it's concave down. Inflection points occur when the concavity changes. So here I've got it's concave up right here. And then at this point, it changes to concave down. And so right here is where it changes at that point. I apparently didn't write down. F double prime of x equals 0 right there. Because here f double prime of x is greater than 0, and here f double prime of x is less than 0, which means where it's changing, it's got to equal 0. Okay? So this boils down to like a second derivative test, and we're going to do the same thing we did before. Pretty much. What we're going to do is we're going to find all the critical points of not the f of x, but f prime of x by using like f double prime of x. And I don't know if critical points is a good word for it. So maybe I should change this and not call it critical points, but potential inflection points. Then we're going to make a sign chart of the regions. Last time we did increasing and decreasing. Now we're going to look at regions where it's concave up or concave down. And make sure, just like before, we're going to use where all the critical values either are equal 0 or it's undefined. Then we'll find the sign of f double prime of x in each region. And great test points to use, rather than just picking random numbers like I did for the first derivative test. Use the points you had for critical values from the first derivative test. We're going to use those as our choices here, because as you'll see, they will help us. They will help us confirm local maxes and mins if we choose those points. Okay? So, and then we're going to use those results along with the second derivative test, this concavity issue, to identify inflection points, and putting in the second derivative test in words. If, ooh, I only got one single derivative listed there. Look at that. That's all wrong. If the second derivative is less than 0, it's concave down at a critical point, which means it's making a hill, which means it's got a local max. If it's concave up at a point, it means it's increasing along that regions. We've got a bull facing upwards. It's the local min, because we're looking at like this point here where it's changing. Well, that's where that's where our critical point is going to be in a second. You'll see. And then if f prime of c equals 0, the second derivative test is inconclusive at x equals c. And we have an example of that here as well. Okay, let's do some examples. We're going to do them in the next video, though. So we're going to do first derivative test, then second derivative test. That's what we're doing. All right, be right back.